So we've dealt with addition, subtraction, and we did multiplication, division. Now I'm going to do a lot of examples of those, so you get the idea. I just want to lay down the rules or properties, or the transition from one phase to another, one level to another. What new powers you have, basically. Okay, and that's taking the addition, subtraction, multiplication, division, moving over to exponents. It really does give you new powers. You can do new things. You can do more things. Where you can talk about more things when you're talking in the language of mathematics, right? Now, there's one additional rule that comes that manifests itself when you go to the exponents, when you're transferring operations, right? We just introduced a whole new level in the game, in the language, where we're taking exponent, where we're taking something and putting it to exponent. So what we're going to do now is, obviously, what's going to happen is someone would have come up with the idea, hey, what happens if this goes to an exponent as well? What if there's another exponent here, right? The way it works is exponents to an exponent, these guys multiply each other. So if you had a to the power of 2 to the power of 3, 2 and 3 multiply each other. So it becomes a to the power of 6. So the way it works is, all you have to have is just a new rule being added on to what we already understood, or what we already learned in the rational numbers, in the base level of mathematics, going up to the exponents. The new rule is, if you have exponent to an exponent, you multiply the exponents. So for example, if you had, where can we start here? 2 a to the negative 2 all to the power of 5. Now, this is the distributive property going in here, and it applies to this and this. And what you do with the exponents is you multiply these guys. For example, if this was a 2 here as well, this would be 2. This applies to this and this. So 2 times 5 is 10. So this would be 2 to the power of 10 and a to the power of negative 10. And of course, negative powers, the way it works is it just kicks down into the denominator, right? So this becomes 2 to the power of 10 over. If you had, for example, 2a to the power of 4 to a power of a half. Again, you have exponent to an exponent. Now, instead of working this from the inside out, work it from the outside in, and you can do this because there's no addition or subtraction breaking these. So what you can do here is multiply the exponents and then apply it inside, instead of applying it inside first and then taking it to the power of a half. So the way this works is 4 times a half. If you remember, again, in fractions, 4 times a half, that's just 4 over 1. When you're multiplying fractions, it's pretty straight up. Top multiplies top, bottom multiplies bottom. 4 times 1 is 4. 2 times 1 is 2. So that's just 4 over 2, which makes it 2. Right? Now, for this becomes 2a. And when you multiply these guys, it becomes to the power of 2. And we already talked about 2a to the power of 2. And this is distributive. This applies to this and this. So 2 squared is 4. A squared is 2. So 2 squared becomes 4. A squared becomes a squared. And that's your answer for this. So 2a to the power of 4, 2a to the power of 4 to a power of a half is 4a squared.